Good evening, all. Welcome to the FDP. Today, we are glad to have our eminent speaker, Dr. Rahul Chaurasiya Garu, Assistant Professor Grade 1, Department of ECE, MA NIT, Bhopal. I would like to give small introduction about today's speaker. So, Sir did his PhD from NIT Raipur in 2017. Master of Engineering from IISc Bangalore, BTech from MA NIT. So, Sir had a lot of professional awards. He is the best recipient of Best Paper Award in 2022 for International Conference in Electrical Electronics Information and Communication Technologies organized in Tiruchi. He is also Best Paper Award in International Conference on Robotics, Automation and Communication Engineering for Industry 4.0. He is also senior member of IEEE. He had a lot of Best Paper Awards, around 10 Best Paper Awards. Sir recently received one grant award for participation in Brain Computation and Learning BCL 2023 workshop at IISc Bangalore during 9 to 13 January 2023. Sir is also recipient of SERB International Travel Support Grant Award to attend 7th International Conference on Control Automation and Diagnosis at Rome, Italy in 2023. Sir had good teaching experience and completed a lot of sponsor research projects. In that, one is development of efficient Devanagari script input-based P300 speller system for brain-computer interface, sponsored by CSRI, Department of Science and Technology. And second one is development of affordable and wearable sensors-based system for automatic detection and efficient monitoring of food intake, sponsored by TechIP 3 Research Grant Scheme, MNIT Jaipur. And third project, he had three projects, sponsored research projects. Third project is thought-based home appliance control system using brain-computer interaction. Sir is actually doing a lot of research in brain-computer interfacing. That is also my research area. And Sir had published 6 patents, and in that 4 filed, 2 granted. Sir had a lot of repeated publications, 22 international journals, 41 international conferences, 2 national conferences, 8 book chapters. He published 2 books and 2 patent grants, already mentioned. Like that, Sir had a lot of research as well as teaching experience in that. We are happy to have such type of personality accepting as a expert person to this FTP. Thank you very much, sir. I hope the participants will enjoy this session and have a great learning day. Thank you very much.
Thank you, sir, for the wonderful introduction.
Thank you, sir.
So, should I start?
Yes, sir.
Okay. I am seeing the option to share the entire screen. Just a minute.
Balakrishna. Okay.
Is the screen visible to everyone?
Yes, sir.
Okay, so sir, how many? I think 2 days are already gone in this FDP.
Yes, yes, sir. Yes, sir.
So I would like to have a little bit interaction with the participants if they will reply that what topics they have already covered in this. So anyone tell me how or what is EEG and have you covered what is EEG? What are different kind of bands in EEG? What are the uses of those bands? Any participant want to reply? Very simple question. What is EEG? From where we recorded? Any participant want to reply with this question? In chat also you can. Okay, so somebody is saying sleep quality assessment. So I will just tell you what topic I'm going to cover. The topic given to me is AI for mental health, EEG-based cognition and emotion analysis. So I will be covering first what is EEG signals, a little bit introduction. I hope most of you have already gone through this thing. What are different acquisition methods? What are different application areas of EEG? Out of those application areas, what is brain-computer interfacing? Introduction application of BCI. Then I will go to the AI and EEG signal processing for mental health. So here I'm covering a topic on which my current PhD students are working, and we are having some research papers on this. We have also filed a patent and writing a book over this. Application in analyzing binaural sounds effect on stress level. So we will see this in detail. Then I will tell you about a brain-computer interfacing data set on which you can work if you do not have EEG acquisition device. And I also will be covering a paper, one of my conference paper, where we are using EEG signal for emotion analysis. So is it okay till now, everyone? At least some reply if somebody is giving, then that will be okay. So there are some reply. Yes, sir. Heart-based ECG analysis, sleep quality assessment. Okay. Okay. So what is the difference between anybody? Please turn on your mic and tell me, because I am confused with this answer. What is the difference between ECG and EEG? Anyone? Just turn on your mic and speak, because I cannot read the comments while my screen is on. Anyone wants to reply? What is the difference between ECG signal and EEG signals? Very basic question. From where they are captured, based on that, what is the difference between ECG and EEG? Okay. So first, let me see the participants. Okay, so let us continue with this. I'm getting some reply. ECG from heart, EEG from. Okay, we are muted. No problem. So let me just continue with this. Basically, electroencephalogram. Electro means electrical activity. Encephalo means the signal coming out of your brain or out of your scalp, that is from your scalp, that is from your brain, and gram means graphy or to study. So the study of signals coming out of brain is called electroencephalogram or EEG signals. So the signals are of very, very low quality. So we know that there are millions of neurons inside our brain. So one neuron produces a signal of picovolt, that is 10 to the power minus 12 volt. But there are millions of neurons. So if you multiply that value 10 to the power minus 12 volt to 10 to the power 6, that is 1 million, it is 10 to the power minus 6 volts. So still, even after, if all the neurons think in the same direction, it is kind of a magnet. All north and south pole in the same direction, if all the neurons think in the same direction, same cognitive effect, then also the signal will be in the range of microvolt. So the EEG signals are very poor quality signal and they contain a lot of noise. So we have to work a lot of things. Once you are working on EEG signal, you have to work a lot of working should be on removing artifacts, removing noise. Suppose you are blinking your eyes, that kind of noise should also be removed. So working with EEG is not very easy. You can download the data set also, or you can record for your own specific purpose. I have mostly worked on my specific purpose and recorded the signals using different EEG machines. So here is a picture that you can see. A person is wearing a EEG head cap and a lot of 64 wires are connected through USB to the computer. So EEG acquisition basically are two types, invasive and non-invasive. Invasive means where you will record directly from within the scalp. Highest quality signal, but very difficult and not popular method. It is not at all used on human beings. Mostly it is used on animals. So when I recorded my first signal, I have seen this facility in IISc Bangalore. There they are having a primates research lab where they do the experimentation on mostly monkeys. On monkeys' head, they have permanent electrodes capped, and from those electrodes, they directly connect like we connect our microphone to our computer or to our mobile, and then audio signal starts recording. Similar kind of thing they use on monkey. There are electrode positions. You just insert the electrodes and start the recording. But for human being, we use non-invasive method. It is easy and convenient. The gel-based as well as dielectrode methods are available, and wire as well as wireless headphones are available. This is an example of very simple 16-channel emotive EEG system, which we have in our lab. So just wear a cap and start the recording. So these are some of the recording pictures from my earlier days of my PhD. And this is the gel-based recording system. Gel is inserted. It is a conducting material to ensure that your hair and your scalp is not producing a proper resistance, and you have a proper conductance from your brain to your directly brain to the signals. So there are light, red light, orange light, and green light. If all the lights are green, that means you are having low resistance and the signals are coming of good quality. So this is an example. Earlier, most of the electrodes were red, and finally, when all of them are green, then only you can start the recording. This process itself takes 10 to 15 minutes, depending on how many electrodes you are using. Some people use 8 electrodes, some use 32 electrodes, 16 electrodes. Here I was using 64 electrodes. So that was a large, very large number. Mostly people can work with 6 to 8 electrode also, but having this large number I was having to see which particular part was having more effect on that particular application. So this is the back part called occipital region, front part, this is your nose. So this is the frontal region, side region is there, central region is there. So which region is going to have more important impact on that particular cognitive task? For that, I was having 64 electrodes. So here is a nomenclature in 64 electrode system. So the C is the central region, F is the frontal region, O is the occipital region. This is your nose, this is the back side of the brain, and these are the 2 ears part. So the names given are like prefrontal, frontal, temporal, parietal, occipital, and central. So you have different kind of system of recording. This is called 10-10 recording system. 10-10 means from this point, from the front point to back point, you have 100% suppose the length, and then that length you divide into 10 percentages. So 10, 20, 30, 40, 50, 60 like this you record. And after every 10% of length, you put the recording electrode. So it is called 10-10 system. People also have 10-5 system or 20-20 system kind of thing. So this is the most important slide in my entire presentation. I would like to describe this in as much detail as possible. If you understand this, then you can understand why EEG can be used for different applications, for disorder detections, for sleep detection. So EEG signals basically are low frequency signals. Okay, the variation of the signal, the frequency variation is not very high. It is 0 to 50 hertz. So if you are recording signal and you are getting high frequency signal, that means it is sure that it is not EEG signal. That means it is some kind of noise that is added with EEG. So EEG are in the range, say 0.5 hertz to 45 hertz. Within that range also, you can subdivide it. So 0.5 to 4 hertz, low frequency, 4 to 8 hertz, some higher frequency, 4 to 8 to 13 hertz, still higher frequency, 13 to 30 hertz, and 30 to 45 hertz. So these are frequency variation. You can have different kind of transforms like Fourier transform or wavelet transform to divide the signal into different subbands. So we call it a bands or subbands. So if I say EEG is a band, then these are the subbands. Or if I say EEG is a signal, then they are called bands: delta band, theta band, alpha band, beta band, gamma band. So some paper write it as band, some write as subband. This is very important to understand what is the meaning of bands. So when you are having a very high or deep sleep, the variation in the signal in your brain is very low. And that kind of signal is coming from deep sleep. When you are having a perfect sleep, suppose 3 o'clock in the night, you are sleeping and somebody records your EEG signal. That signal will have very less variation in that amplitude. The frequency variation will be very less. So that signal is called delta signal. So 0.5 hertz to 4 hertz is the delta signal or deep sleep signal. Then suppose you are having a light meditation or light sleep, you are awake but not thinking too much, just awake, blinking your eyes and just having some calm meditational state, then that signal is called theta signal. So if you are having less stress, you are having high mental peace, you will be releasing more theta signal because you are not sleeping but you are calm. So 4 to 8 hertz signal is called theta signal. Then you are doing some cognitive task. You are solving some numerical, you are listening to someone and trying to analyze what he's saying. Okay, that kind of signal is called mostly alpha signal. You are physically relaxed and thinking little bit. That's is called alpha signal. So from low to high, you can see more use of brain for different application. It will be more alpha and beta signals. Beta signal is you are having more alertness, most focused, problem solving skills. Suppose you are giving an exam of JEE Advanced or you are giving the exam of GATE. A lot of thinking is going inside your brain. You are solving a lot of numerical problems. So then your brain will be releasing mostly beta signals. And if you are having hyper alertness or some kind of stress or hypertension, then only your brain will be releasing gamma signal, 30 to 40 hertz range frequency signal. And if the signals are of higher frequency than this, then they are not EEG signals, they are the noise signals. So I think you can understand the lower frequency signal comes when you are very relaxed state, maybe when you are sleeping. As soon as your brain starts thinking in different directions, different tasks, the frequency of the signals increases up to the level of hyper alertness or stress level. So can anybody suggest me, if I am one person is sleeping and another person is in very high stress, so how you can find using the power of the signals, which particular person will be having high power in delta signal, whether the one who is sleeping or the one who is having hyper alertness? So I think the question should be clear, then only you will understand. There are two persons. Person A is sleeping in deep sleep. Person B is having very high stress, thinking too much, whether what will happen tomorrow after my result and all, like the CC thinking person B. And what I did analysis of power of the signal. I computed how much is the total power of the signal in different subbands, delta, theta, alpha, beta, gamma. Person A who is sleeping, whether he will be having high power in delta or gamma. That is my question. So you just need to write for person A, what should be the power? Where the chat can we see? Now I'm seeing. Okay. So are you getting my question? If a person is sleeping, whether he will be releasing more delta band signal or more gamma band signal. Delta band is very low frequency signal and gamma band is very high frequency signal. I just want to know if somebody is listening to me. Okay, so gamma band, I think the answer is not correct. Gamma band is released, high frequency signal is released when you are at hyper alert stage. And delta band is released when you are having very high sleep level stage. Okay, so if I'm asking person A who is sleeping, obviously more power will be in delta band. And if a person is not sleeping, he is having some cognitive task, more alpha band signal will be released. And if a person is very hyperly active, some kind of stress he's feeling, then gamma band signal will be released. So this is the basic thing which I think anybody can understand. So the analysis of EEG can be done by mathematical methods. You can take the signal, you can take the amplitude of the signal, you can take different kind of transforms, wavelet transform, Fourier transforms. But most important is to understand what the signals wants to say. Suppose you want to calculate the power in different bands, or if you want to see which signal is released more, and if the delta and theta are released more, you can say the person is having less stress, perfectly calm, having proper sleep. And if the beta and gamma signals are released more, the person is becoming more alert, trying to solve more difficult problems, kind of hyper alertness, or those kind of things are there. So here also you can see in this diagram, these are the simple signal, very low variation in frequency, and these are very high frequency variation signal gamma. So it is not like every time you should release only these delta and theta. These are released when you are calm. Alpha and beta should be released when you are having some kind of problem solving task. But when you are having very high gamma signal, that means that is a sign of alert. That means you need to do some kind of meditation, or you need to reduce that gamma signal by having some kind of meditation, or diverting your mind from those tasks which are giving you this gamma signal. So I think EEG can be used for mental analysis. That was the task of this particular topic. So I think it is very simple to understand that suppose you record EEG signal from some person, and then you try to find the different subbands and see which subband is released more. If it is gamma, that means there is a requirement of pacifying the person, there is a requirement of giving him some kind of meditation. So for mental health to be good, the gamma signal should be less. And in night, if you are sleeping, delta should be more. If you are calm, theta should be more. Alpha and beta should be more only when you are having some cognitive application. So extraction EEG waves using DWT. DWT is called digital discrete wavelet transform. What you can do, you can have a signal. Suppose you are having a signal of 0 to F. F is suppose 50, 0 to 50 hertz. So what wavelet transform does, it divides the signal into two parts, approximation and details. Approximation is basically the low frequency signal, and details is the high frequency signal. So 0 to 50 hertz, A1 is 0 to 25 hertz, and D1 is 25 to 50 hertz. So the 25 to 50 hertz is the detail part, which I can say is the gamma band, because you see here 30 to 45 or 25 to 30 is the gamma band. This again, A1 you can divide into A2 and D2. So from 0 to 25, you can divide into 0 to 12.5 and 12.5 to 25. Again, this 12.5 you can divide 0 to 6.25 and this 6.25 to 12. So if you combine A3, D3, D2, D1, you can get back the sample signal, the original data. Or you can say this is the signal near the delta band, this is near gamma band, this is near beta band, alpha band, and delta band. So this is a very simple one-line code where you can divide the signal into different subbands. Here is an example. This is a sample data, and then these are D1, D2, D3, D4, D5, 5-level decomposition, and A5. A5 is basically the lower frequency signal, delta band, and this delta, theta, alpha, beta, gamma. This is the gamma subband. So this is very simple. You can divide the signal into subbands. So I think now you understand that EEG signals are very important kind of output from our brain. If they are having different subbands, we can say based on different subbands, which particular subband should be having high frequency and low. Now suppose you are concentrating on alpha band signal. Alpha band signal are released when you are having some cognitive application. You are thinking something, or you are given some task and you are reacting on that task. You have been shown some image, some videos, and whether it is a comedy video or whether it is a sad video, and based on that you are reacting. So the brain signals will change in that alpha band, because most of the signals will be alpha band when you are realizing or having some emotional impact. Suppose you are listening to a video, you are viewing a video where there is a lot of comedy, so more happiness will be there. If you are having some video where a lot of anger should come, so that angry will be there. So in those alpha band signals, you can have some kind of feature extraction technique in machine learning, and then you can understand which is the emotion out of that. So the application of EEG is in brain computer interfacing. So we will see what is brain computer interfacing. It is also neurology, which is used to detect disease like epileptic seizure, that is epilepsy related disorder, memory problems like Alzheimer's disease, seizure detection, sleep signal analysis, whether you are having a proper sleep or not, anxiety detection, coma detection, consciousness detection, mental disorder detection, and lot of other OCDs there, obsessive compulsive disorder detection. These are the basically medical problems where you can use EEG signals to recognize some kind of disease. You can also use it in neuromarketing. This is the newest branch of advertisement industry, like Amazon and all are working on this, where what they are doing based on your reaction on their product. Suppose on your screen they are showing a lot of shoes and you are happy, that means you want to buy the shoes. But if they are showing a lot of jackets and you are having some kind of a neutral reaction, that means they know that you do not want to buy the jacket. So this kind of research they are doing on their volunteer subjects, that which particular type of product are having more response, that means that product he is interested in buying. So this is called neuromarketing, brain signal analysis based marketing. So this is a relatively new research topic. Okay, so these are the application of BCI. I will just see if somebody has typed something, or if you have some doubt, you can ask. Okay, so let me continue. Okay, I will keep this chat here. So in brain-computer interfacing, basically a communication directly from your brain to the computer without you using any audio from your, you are not speaking, you are not giving any kind of gesture, you are not moving your hands, you are just thinking, and your signals are being analyzed by machine learning methods to see what you want to say. A brain-computer interfacing is a direct communication pathway between human brain and external device, and it does not require any medium of communication such as talking, gesture, writing, etc. So I did my PhD on this, and I also got a project from DHT on this P300 speller system. We will see what it is. So you get the signal like any other machine learning method. You get the signal, you do the pre-processing, because we have already seen that EEG signals are very prone to noise. So we need to remove noise by using a lot of filters and all. You can have to, you need to also apply the filters in 0 to 50 Hz range. Then you extract some features. You may extract statistical features like power of the signal, mean value, absolute value, zero crossing rate, all those kind of features. And then based on that feature, you will classify the signal to detect some task or some of the applications, and you can use it for BCI. So this brain computer interfacing can be used for speller. Speller means you are, suppose in your computer you are using a keyboard. From keyboard you are writing and it is being used to write. So you can use this BCI system to spell words, to write something only by thinking within your brain without even typing or without even speaking. So this is an application of spellers. You can have wheelchair control. Suppose you are thinking that my wheelchair should go forward or should move left or should move right or should go backward or should stop. Those kind of tasks can be done using brain computer interfacing. You can have keyboard control, 2D cursor control. That means you can move your cursor in different directions. You can have mobile screen control, robot motion control. So wherever you are thinking, and you can have the output done. And home appliance control system. On this topic, I have supervised one PhD where we have published more than 5 papers on this particular application, home appliance control using brain computer interface. Okay, so let me just tell you a very good application. Mostly I will be discussing the applications here where we can use this, and also later I will tell you how EEG signals can be used for emotion analysis. So that in the initial slide I already told you. So P300 speller system is called event related potential. That means we have given some task or some event to perform. And in response to that event, the EEG signal will have some kind of voltage or some kind of signal or potential. So that is called event related potential. Somebody, suppose you show a person a lot of white balls and suddenly you show a black ball, then lot of white ball and suddenly a black ball. So the occurrence of that black ball, the probability of occurrence of that black ball is less. So whenever that black ball comes, the person become highly alert. And after showing that black ball, after 300 milliseconds, there is a positive peak in the signal. So it is like this signal and continuously very high peak. So that is called P300, a positive direction peak after 300 milliseconds. This is also called odd ball paradigm. That means if the ball is having lesser probability of occurrence, then that particular thing will happen. So based on this P300 signal, so P300 basically nothing but a type of response in EEG signal, you can design a speller. In general, P300 speller basically can be used as a computer keyboard. It's a medium of communication for people suffering from various motor disabilities and not able to communicate by muscular activities. So where this system will be used, it will be used for visually stimulating a subject, who is not able to talk, who is not able to speak. A very specific minority of people may be having some kind of coma and they are able to think but not able to respond. So they can use this system. Okay, so what you have to do, first you have to stimulate a subject using the display paradigm. So whatever keyboard, suppose your keyboard having QWERTY, alphabets, numbers, and special characters and all, so you have to display those characters to the person. Then by showing those, you will record his brain response or EEG signals, whatever system or whatever word he's trying to speak. Then you will pre-process the signal, do the feature extraction and classification to find out which particular character he was going to tell. So this is an example. You have to display the characters which you want him to communicate. He will see the characters and then he will respond. You will take the signals, you will do pre-processing classification to find out which character he is going to say. So this is an example of row column paradigm. So here what happens, you can see A, B, C, D, E, F, G like this till Z and some numbers and a dash. So this is a 6x6 display paradigm, 6 rows and 6 columns. And suppose, and this you can see third row is intensified. It is very quick. For 100 millisecond, it will be intensified, then everything will become black, then maybe randomly this column will intensify, then it will stop, then maybe this row will intensify. Randomly rows and columns are getting intensified or blinking. So suppose the person wants to speak T. So his focus will be on T. So whenever the light comes on this row or this column number 2 or row number 4, the person's brain will respond in terms of P300 signal. P300 signal is what? It's a signal generated having a very high peak, kind of that very high peak signal after 300 millisecond of showing this T. As soon as he sees the T, after 300 millisecond of that will be generated. So we do not know whether it is generated by S, T, U, V, W, X, because whenever this row is intensified, the person's brain will generate the signal. But also that there is a column, maybe on this column. So by knowing which particular row and which particular column is generating that signal, we will be able to tell that person is communicating T. So we can see the pattern. Whenever the fourth row and second column is intensified, the person's brain is responding in terms of P300 signal. So we will say it is a character T. After T is communicated, it will be displayed and the person will focus on the next character. Like this P300 speller system works. So there are different kind of paradigm. This is the row column paradigm. Then there can be single character paradigm. This is called checkboard paradigm, region-based paradigm. So different kind of paradigm are there. Basically, all of them displaying different characters in different fashion. First is displaying in the terms of row and column. Second one is displaying in terms of only one character at a time, but it will take a lot of time, lot of iterations to display that particular character that he wants to communicate. This is checkboard where only odd or even is displayed at a time. Okay, then there are region-based paradigm as well. So how it works, I already told you oddball paradigm. Whenever the probability of occurrence of that particular event on which you are focusing is less, suppose in this row column paradigm, the probability of occurrence of this or intensification of this row is 1 upon 6. Out of 6 row, this will be intensified with the probability 1 upon 6, or the column 2 will be intensified with the probability of 1 upon 6. So overall, this T character will be coming in 2 rows or columns out of total 12 rows or columns. So the probability of occurrence of T is 2 upon 12. It is less than 50%. So that will generate a P300 signal. Okay, so this kind of experiment, if you can design, you can generate a P300 signal. Lesser the probability of occurrence of the event, more is the chances of having a high quality P300 signal. Okay, so this way you can generate the signal and you can find out what the person wants to communicate. This experiment is called oddball paradigm. So here is the difference. The red signal is a common EEG signal, whereas the blue signal is a P300 signal. You can see this is the timeline, 0 second, 200 millisecond. After 300 millisecond, there is a peak in the signal. So if this peak is there, that means the signal is coming out of some kind of stimulation of oddball paradigm. So you can find out when this peak was happening before this or 300 millisecond before this, which character was intensified. So by this, you can find out what he wants to communicate. So this is the method of working of P300 dispel system. So here what happens in the training phase, we will ask the person to focus on the character which is written there. And based on the analysis, we will display the output here. Once the training is completed in the machine learning, then in future, we will not have this input to him. We will just ask you, you keep on looking the character. We will display the output which you are seeing here on the second text result. This text to spell is there only for the training phase. So what I did, I thought maybe there are some people who are not able to understand English character. And a lot of people in India use Devanagari script. It is used in Hindi, Marathi, Sindhi, a lot of languages. In fact, if you see the all languages which use Devanagari script, it is the third highest speaking language in the world. So after English and Chinese, I'm not saying Hindi is the highest speaking. Combination of Hindi, Marathi, Sindhi, and Nepali and all, which uses this particular display paradigm, they are combinedly the third highest speaking. So I use this 8x8 paradigm because the characters are more. So the chances of generating the signals are more because the paradigm is of having lesser chances of generating that particular character. Suppose he wants to communicate a character, look, ta. So the probability becomes 2 upon 16. It was earlier 2 by 12. But there are some other effects. Other effect means there are similar looking characters. Some persons do not know the order, so they do not know where to find that character and all. So the signal quality overall becomes very poor. We had to use a very good classifier system, optimization system, deep learning and all on the EEG signals to accurately detect the character. Then we used the same application for home appliance control. So in the computer, we were displaying different on screen, different kind of appliances like TV, mobile, door, AC, light, and all. The person was focusing on one of them. Suppose he's focusing on door. So once the door is detected, we change the display here. And now the options are for opening the door, closing the door are coming. And whichever character is focusing on, that particular character is being used. So this was the application prepared, and based on that, suppose he wants to open the door, we use the Arduino board to give the command to door to open it. So this was the application of home appliance control. Okay, so suppose this is the application TV, fan. This is called display paradigm. This is all being shown. And suppose he wants to operate the TV, then the options are coming on the TV, off the TV, channel down, channel up, like this. So these are the different paradigms that we designed. This was for TV, this was for telephone to dial, this was for opening or closing the door, this was for decreasing and increasing the geyser temperature, light on, light off. There were different options. So at a time, only one screen will be shown to him based on which particular appliance he was selecting in the first phase. So process flowchart was like this. We collect the data, we pre-process it. Pre-processing is very much compulsory because we need to remove the noise and artifacts. Then we use the deep learning model called EEG-net, one-dimensional convolutional neural network, EEG-net, to classify, to detect the intended target. Once the appliance is detected, we send the signal using Arduino board to that appliance to operate. Okay, so now I come to the topic which is given to me, AI for mental health. So how many people agree that by listening to the meditational sound or a different mantra like Om, your brain will be pacified or your stress will be released? How many people believe in this? If you're listening to me, can you tell me? If you are having very high kind of hyperactive and all, and you listen to the music, favorite music of yours, or some songs from the literature, like some people listen to Hanuman Chalisa, some people listen to some kind of mantra, Om and all. So that is for sure. Okay, yeah, somebody's saying yes, sir. So whenever you're listening to the Vedic mantras or and all, yes. So a lot of people are writing yes. So when you listen to this kind of music, it is clear that your brain will release EEG signals which are not hyper alert signal. It will not release gamma signals. It will release theta signals. Theta signals are the signals which tells a person is having low frequency signal, gamma signal. It is in the range 4 to 8 hertz. If you remember this flow chart, again I will tell you. This is the flow chart, 4 to 8 hertz theta signal when you are having meditation or light sleep. So if you start listening to Om sound or some music you like, especially the dharmic music, then your brain will move the signals from gamma to theta. So this is an assumption, or this is a very, very well-known fact. But how mathematically you can prove it? So we did some application on this, that there is a person who was having hyper alert. We first found out whether he's hyper alert or not based on questionnaire, how he's feeling. If he's feeling that he's having stressed or having gamma signal, then we gave the input of meditational sounds, and we have seen that his signals are shifting gradually from gamma to theta. That means he's having better mental health over the time. Now suppose this person is having a stress related disorder. Disorder means he's having a permanent disease of having high stress again and again. That kind of disorder is there. Doctors will tell him that this is a disorder. You are having that kind of disease. It is like fever. Fever is there, we can measure. So doctors, neurologists can measure that you are having a hyper alert or stress related disorder. That means you need to have some kind of meditation. So nowadays there is a signal called binaural sounds. I will come to the slide again. This slide. There is a signal called binaural sound. That is kind of a healer. That is kind of a medicine for the person having stress. What the signal does? Bi means two different frequency. We know that sine omega t is a one single signal, one tone or single tone signal. If I say sine 300 t, that means it's a signal of frequency 300. Sine 500 t is a frequency 500 signal. So we can have different single tone signal. Single tone means single frequency sinusoidal signal. So what is a binaural sound? We have two different signals in two different brains. Suppose this is 500 hertz single tone signal in right brain, right ear, not brain, right ear. So this require a headphone or earphone. It cannot be given simply by a speaker because the speaker will mix both the sounds. You have to separately give two different sounds in ear using earphone or headphone. and the other is suppose 193 hertz. So what our brain does, it does not process the 500 hertz and 493 hertz signal. The brain processes the difference of the signal. So suppose the difference is 7 hertz. So the brain will analyze and process that 7 hertz frequency. And we know that 7 hertz frequency is within that 4 to 8 hertz range. So over a time, suppose after 10 minutes of listening to this sound, your brain will start releasing the signals instead of delta of high frequency range or gamma of high frequency range of 40 hertz, it will start releasing 4 to 8 hertz theta signal. That means you are going in a high level of meditation. I think you all can do experiment this within yourself. You can have a YouTube audio where there is a binary output. Just write there binaural beats or sounds and start listening to those binaural beats in your ear, and you will realize that after some time you are feeling relaxed. So we are doing an experimentation on this. We have taken 9 subjects. To all of them, we have first given a lot of mathematical questions and all, so that they come to hyper alert stage. Lot of difficult problem and all. They came to hyper alert stage. Then we have asked the questions and all, and we consulted doctor. He told, okay, they are now in stress condition. They are temporarily stress condition. Some people are permanent stress condition. So we asked them to be in temporary stress condition. Then we have asked them to listen to this binaural beats. So after listening to this binaural beats, their minds is getting into meditational stage, and they are giving output in terms of low frequency signals. Their brain are giving output in terms of low frequency signal. They are analyzing that using machine learning tools and all. So this is an application. The binaural beat is a low frequency sound generated when a person is made to listen two slightly different single tone waves at different ears. Traditionally, the frequencies ranges from 200 to 900 Hz. So this is her example is 500 Hz. And the difference lies between 1 to 30 Hz. Generally, people give the difference between 4 to 8 Hz to keep it in the theta range. So this was the experiment we performed. We have a sound source in terms of a headphone given to the person, and the response was recorded in terms of EEG. So instead of video stimulation or image stimulation, we are having an audio stimulation by asking him to listen to the sounds which are directly coming from YouTube. Listening to those signals, we record the EEG signals. We used a 14-channel Bluetooth device. Those signals were captured in our PC. We did a lot of pre-processing and classification, extracted the feature and all, and using the machine learning method, we found out whether there was a shift in the signals from higher frequency to lower frequency. And we validated that it was being done. That means the binaural sounds are quite effective in reducing the stress. So there are 2 parts. Whether you are using binaural sound or some other meditational sound, that is okay. But to mathematically validate that, you need to record the EEG signal. You need to see the power in different bands. And if the band's power is shifting towards the lower side of the frequency, that means the person is getting towards the meditational and sleep stage. So this was the part we used as a time. So we have given the person a 2 minutes of resting time. Before 0, this is -1, -2, 2 minutes of resting time. After that, we started the binaural beats and recorded the EEG signals. Initial 2-minute signal we called pre-signal. Middle 2-minute signal we called mid-signal. And last we called post-signal. So pre-signal, there were more power in higher frequency bands like gamma band. In mid, the power shifted towards the alpha and beta. And in the end, the power shifted towards the delta and theta, where the person started to feel like sleepy. He was almost like going to have a proper sleep. That means a person who was having hyper alertness was going to the sleep stage by listening to that particular sound. And these sounds, a lot of people use as a meditation nowadays, especially the person addicted to alcohol or tobacco. They are giving this kind of sound as input to relax their mind. So this was the experiment done. So how the impact of binaural sound was done on stress level, that was analyzed using the EEG signals. The impact of binaural sound on stress level can be analyzed by acquiring and processing EEG signals from each subject before and after the binaural beats applied. So see here figure, before means at the initial stage and post means after the last stage or after that particular time. In the 20-minute recording session, we recorded first 2 minutes. We analyzed the signal for first 2 minutes, middle 2 minutes, and last 2 minutes. Change in EEG signals are observed before and after the application of binaural sound. For higher stress level, signal power should be high in beta and gamma subbands. And for lower stress level, power should be shifted to the delta, theta, and alpha subbands. So we have observed that gradually the power was shifted over the 20-minute of period from the higher frequency signal to the lower frequency signal. So here is an application where EEG can be used to analyze the emotional state. Okay, so some of you might be interested in working with EEG signals or brain-computer interface, but may not be having that EEG acquisition device in your institute right now, because generally institute does not provide these things. You need to buy them from the funding through different projects and all. This device we are having in our department. So for that case, you can start working initially with publicly available data set. So there is a data set called BCI Competition 3 dataset, Brain Computer Interfacing 3 competition dataset, and BCI Competition 2 dataset. This is 2002 competition, 2004 competition. There is a link to that. I will provide this to you. Lot of applications, cursor control task, P300 speller task, binaural sound task. So those are signals they are given to you. Now you can apply your machine learning models to analyze and to classify the signals and all. And there is a software if you want to record the signal and give different kind of audio and video stimuli. The signal software is called B300 BCI 2000 Contrib software. This is free software you can download from the BCI 2000 website. You will just need to write that I want to use this for the research purpose, not for the professional application. So you can require the data set as you want. And this is one of the device which we are having. There are different devices available in markets. This is called Epoch 14-channel wireless EEG dataset. You can have the device from a company called Brain Products. There are other companies also, Biosemi. Lot of companies are providing this kind of device. This is an example of simple 14-channel. Here you can see the 14-channel system where these were the standard channels, AF3, F7. So all these left side are the odd one and the right side are the even one. Numbers are given like this. F is for frontal, O is for occipital, C is for central. These are the sample example signals that we have recorded during the experimentation. So in this, I will stop with what is the EEG and all. I will also give you one example again after this of emotion analysis using the EEG signal. Emotion means that emotion of anger, fear, sad, neutral, how that can be analyzed using EEG. So any doubt here to anyone? Or any question if you want to ask? I thought this will go to 1.5 hours, but because there are no questions from the audience, so the PPT is over within 1 hour. List few more applications on BCI. This is one question. So I have listed. Okay, somebody is asking what is the approximate cost of device. So the device which you can use for acquiring EEG signal starts from the cost of maybe say 10 to 15,000. NeuroSky is the very simple one. NeuroSky cost around 10 to 15,000, and it can go up to 2 lakh rupees, up to 10 lakh rupees, up to 1 crore rupees. So if you see this device in my PPT, this one is 50,000 rupees because it is not available in India. I purchased from US, so it was approximately 50,000 rupees. And this one was very costly, which I used in ISC Bangalore. They told me, the professor there told me that they have purchased, it is a 128-channel electrode device by a company called Brain Products. So it is mostly dependent on like in electrode, how better is the amplification, whether the electrodes are made of gold. Here the electrodes were made of gold because gold has the highest connectivity. So this device for them costed around like 1 crore rupees. But you can have a device called NeuroSky, which cost only 15,000 rupees. Okay, so the question is any data set on EEG for sleep arena diagnosis. Mostly you will find a lot of data set in BCI 2000 competition. How many electrodes are required for recording the applications? You may start with as less as 8 number of electrodes. So generally people start with 8 electrodes. Still they do reduce. So there is a question, how many electrodes are required? I started with 8 electrode and then I optimized that only 2 electrodes are required, because if less number of electrodes are required, it is more user convenient. If a user is using only 2 electrodes, it is very convenient for him. Home appliance control by EEG signals, yes, it was achieved, but it is a very specific application. Only for few people will be using home appliance control using EEG, because speaking through your voice, just like Alexa, turn on the fan, that is more easy than wearing a head cap and then thinking and then reacting, but it is used for the person suffering from some kind of motor disability. Python libraries for EEG analysis, yes, there are there, but we generally use EEG Lab. EEG Lab is used with MATLAB. EEG Lab is a free software. With MATLAB we use. Python also can use it for analysis and all. This Parkinson disease data set, I do not know because I haven't worked on it. Minimum channel required, I have told you, up to 4 channel or up to 8 channel also you can use. Okay, PhysioNet dataset I have not worked. I will tell you recently, if my screen is visible. Recently, I worked on one book, edited book, where I have collected lot of chapters from different people. 16 chapters we have collected on application of AI tools and EEG signal analysis methods for brain related disease detection. So we got papers related to OCD, obsessive compulsive disorder detection, Alzheimer's detection, brain disorder detection, bipolar detection, brain computer interfacing. So whether my screen is visible now? Anyone? Okay, so I will tell you some of the. This was the preface I made after taking all the chapters. So we worked and got chapters on these topics in our mental stress reduction, psychological disorder detection, obsessive compulsive disorder detection, seizure detection, post-traumatic stress disorder detection, brain tumor segmentation, Alzheimer's disease detection, and motor imaginary classification, inner speech EEG classification, neuromarketing. So these were the area where we got the papers and we accepted them in our chapter, in our book. So there are a lot of other applications as well. You need to find them. The most important thing is that if you can divide the EEG signals into subbands, you can do a lot of things with that. Okay, I think he's saying the screen is stuck. Maybe because I am sharing only my PPT. Application window, what to share, I do not know. Is my PPT visible now? Okay, so let me share the PPT only. Is this paper visible now? Okay, so this was a paper, very simple data set was there, sequential study of emotions through EEG using HMM. So HMM is basically a sequential data classification method. Sequential data classification means in machine learning, we have two type of methods. One kind of method is used for images, like convolutional neural network you can use for images, support vector machine, k nearest neighbor classifiers. Okay, and there are some kind of data which is called sequential data. Sequential data examples includes audio data, stock market data, weather forecasting related data, and EEG data. These are sequential one-dimensional data where the data order monitoring mental health using only EEG signals valid or any other parameters need to consider. Okay, so I'm going to answer this question to Priyanka. Sequential study of emotions through EEG. Not only EEG, we are using lot of other signals also. We are seeing how EEG can be used to see the sequence of the emotion. So suppose a person is given 2 minutes audio or maybe 6 minutes audio. Starting audio is comedy and the last audio is sad. So his emotion will change from comedy to sad or from happiness to sad. So we did a sequential analysis. We divided the signals into 10-second signal, and we for every 10 seconds we saw the transition from one stage to. If frequency is not accurate, then the signal is connected or not. If the frequency is not accurate means what? You just plot the signal for Fourier transform, and most of the power should come in the 0 to 50 hertz. If it is coming outside, that means noise is also recorded. You need to remove the noise using different kind of filters like Butterworth filter. Okay, my voice is low. I don't know why, because I am using the same system. So I'm giving an application here of emotion recognition. What we did, we have taken a data set. It is mentioned here, a deep data set. It's called DEAP, deep data set. It is the EEG data in response to different audio signals or videos given to different people. This is publicly available data set you can download. On that data set, we applied hidden Markov model. It's a sequential data classification model where we have 4 probability metrics called initial probability, 3 probability matrices, initial probability, transition probability, and emission probability. So we have found these probabilities values using the data set. And we used EEG signals, GSR signal, blood pressure, other signals as well. So different kind of signals were used, and different kind of, not only EEG, other kind of signals were also used. And we have taken all those features, passed to this model, and the model has shown us the transition from emotion from one stage to another stage. This paper was published in the conference, but it is just to show that there is a publicly available data set available for emotion recognition using EEG, and you can also classify it. How to extract time domain feature? So basically, it's a one-dimensional signal. I will tell you very simple. Suppose if it's a one-dimensional signal, the one-dimensional signal is nothing but a sequence of numbers. It is kind of a amplitude values written in terms of time. So suppose the value is 1, 7, 8, 2, 9, 3. That means different amplitude at different time. So you can take the mean of the values. You can take median, standard deviation. So these are the time domain features. You can square them all and divide by the time value. That is called the average power. So these you can take zero crossing rate. Zero crossing rate means how many times the values are changing from plus to minus and minus to plus, because whenever they are changing from plus to minus and minus to plus, they are crossing the zero. Zero means that x-axis line. So these are the features. Very simple code you can have in MATLAB or Python to extract the features like this. Okay, so here my presentation I will stop. I told you about what is EEG, what are the applications, including in brain-computer interfacing. You can use it for emotion analysis. You can use for meditational signal analysis, binaural sound analysis. If there are doubts, we can discuss. Or maybe I will ask her to stop it. monitoring mental health using only EEG signal is valid or any other parameter need to be considered? The question is again, so maybe some other parameters are also there, like you can have blood pressure, sugar level and all. But as I'm not a doctor, I'm a researcher in the field of biomedical signal. So we have worked only on EEG to show, because only EEG can also work, but the other can also validate. We have used only EEG to show whether the person is having high stress or not. But other parameters I think may also be used related to cardio ECG signals, related to blood pressure signals. So that a doctor can tell in detail what other signals you should consider. Any other doubt? If there is no other doubt, we can stop the presentation now. Okay, I hope some people have heard, because I have also attended online lectures. Mostly people just turn on the screen and mute it just to get the certificate. So if there are a lot of questions here, I hope that for research, non-invasive method of treatment is used. Yes, non-invasive method only is used. Invasive means it is used only on animals and you need a proper kind of ethical committee approval and approval from lot of doctors and all. How to unmute? I need to stop because generally I use Google Meet, so I am not very sure with this. Stop sharing. I think admin can mute or unmute anyone. There is a question, what is the scope for research in EEG signal challenges? Okay, sir, I am the host. I do not know host tools.
Yes, sir. Yes, sir. You're the co-host.
Okay, you are on mute now.
Yes, sir.
Sir, actually, people want to ask some doubt. Can you unmute all of them?
Yes, sir. 1 minute.
Done, sir. Done.
Okay, so I think now all of the participants are unmuted. If they want to speak, they can turn on the mic and can speak. If there are some doubts, we can discuss.
Sir, BCI system, what are the other benefits for the patients who unable to move, sir? What are the, you showed some wheelchairs and some motion something. What are the best other applications like using BCI systems mechanism?
Sir, using BCI, we have seen applications like P300 speller system, and there are other speller systems as well. Basically, you can spell out what you want to speak. You can have wheelchair control. You can have drone control. Nowadays, drone control is also coming. You can have home appliance control. So basically, any kind of visual stimuli you give or audio stimuli, visual stimuli mostly, where there are options to choose. And he will select those options, and that command will be going to computer. So based on that, whatever application you can design, that you can design. That is up to your things.
For example, a person is unable to move his hand means a separate a artificial limb is connected to him. He can also control that one also, no, sir, using BCI.
Yes, yes. But for that, mostly people use EMG signals.
EMG.
Hmm.
Okay, sir. Okay.
Okay. Any other doubt?
Hello, good evening, sir.
Okay.
Yeah, I have one doubt. Sir, how EEG is useful for sleep stage identification or sleep apnea detection?
Yes, as I told earlier, that if a person is having proper sleep, the signal power will be more in delta band, which is 0 to 4 hertz. Okay, so you can classify the signals, the recorded signals. Suppose he's sleeping for the entire night, suppose you record the signals. And if the signals are never moving to the delta band, that means the person is never having the proper deep sleep. And if they are moving for some, suppose 2 hours to that stage, that means for those 2 hours he's having a deep sleep. So I have not done much research on this, on deep sleep. My mostly research is in brain computer interface, but this is the basic fact which I know, that by analyzing the signals of EEG of a person and seeing how much time it is having mostly in delta band, you can find out. Delta means lowest frequency band. You can find out whether it is having a deep sleep or not. Okay.
Yes, sir. Thank you.
Dear participants, any doubts? Sir is ready to
Sir,
answer
I am
your
the
all
beginner.
questions.
Sir,
Yes, Shankar, tell me.
one. Hello, sir. Can I ask last
Yes,
doubt?
yes.
Yeah, suggest me. I am the beginner for the EEG signal for research domain, sir. What are the resources? Can you share any as a beginner for EEG domain?
Okay, so I already shared this, but I will again share with you.
Okay, sir.
These are 2 websites.
Okay.
I will write this in chat. Just a minute. This is called Brain Computer Interface BCI dataset. Okay, and there is also the deep dataset. This is for emotion. This one simple example. So there are a lot of data set for Alzheimer's disease detection. There are a lot of data set for, basically you can start with the data set first. You download a recorded data set, and based on the data set, you classify them using machine learning models. Mostly I give this task to my BTech student because they are good in coding in applying machine learning models.
Yes, sir.
They classify them, and afterwards you can record your own signals by going to different, if you have the machine, okay, otherwise you can go to some university nearby where they have the machines available, EEG acquisition machine available. You can record for different applications. So first you have to decide whether you want to work on some disorder detection, some disease detection, or whether you want to work on brain computer interfacing. If you want to work on disorder detection, maybe you will also have to consult a doctor. Whether the person is having the disease or not, that is very important. Or you can download the data set. Suppose Alzheimer's disease, there are a lot of data sets available. OCD, I told you there are a lot of data sets available. So you have to first understand what particular application you have to work. Then only you can start. Okay.
Okay, sir. Thank you. Okay, sir. Okay, thank you.
So should we close here, sir?
Yes, sir.
Can I leave?
1 minute, sir. Just I would like
Okay.
to thank you.
Okay.
Sir, in spite of a busy schedule, Rahul Chaurasiya sir accepted our invitation. This is the second time sir has giving presentation on BCI in our institute. 2 years back, he had participated in as a keynote speaker. Now, today also he has given wonderful lecture on EEG signals, how to start the research, what are the different types of signals, how to classify the signals, and he shared a lot of views regarding his research and what are the applications of BCI. So next, what are the future applications of BCI also? What are the future research? Thank you very much, sir, for a wonderful lecture. Thank you, one and all. Have a good day. Good night. Thank you, sir.
Okay, sir.
Thank you. Participants, next session will be tomorrow. So today's session actually sir is not available. So he will take tomorrow. I posted in the group the timings. Thank you, one and all. Good night.